So we continue looking at more concepts, and today we're going to be looking at calculating mole, mass and volume from equations. So balanced chemical equations can be used to replace sentences describing reactions. Equations give the actual ratio of the reaction particles, that is, Roman numeral 1, the ratio of moles of reactants and products, Roman numeral 2, the ratio of mass of reactants and products. However, the exact amount of reactants and products can be calculated from chemical equations. An example of a balanced chemical equation is given below. So let us look at an example of a balanced chemical equation. So for example, if we have hydrogen plus oxygen, this we know that this produces water. So we have hydrogen plus oxygen, this produces water. And if we start counting the number of hydrogen and oxygen on the reactant parts and on the products part there. So here hydrogen we have 2, hydrogen we have 2. So hydrogen is balanced. But here oxygen we have 2, oxygen there we have 1. So oxygen is not balanced. And to balance oxygen there, we are going to add a 2 there. That means that oxygen there 2 and oxygen there 2. But here we have hydrogen 4. And to balance up hydrogen, we are going to add a 2 there. So this is a balanced chemical equation of the reaction of hydrogen plus oxygen to produce water. So from this balanced chemical equation, we can say that we have Roman numeral 1. We can say that 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 1 mole of water. So 2 moles of hydrogen gas there, as you can see, we have 2 moles of hydrogen gas reacts with 1 mole. We only have 1 mole of oxygen gas, and that produces 2 moles of water. So we have 2 moles there. So we can write that down. So we have 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to produce 2 mole of water. So as you can see here, we have 2 moles of hydrogen gas. So we have 2 there. Then reacts with 1 mole of oxygen. There we know that we have 1 there to produce 2 moles of water. And we know that we have 2. Then the other thing that we can say, and that's going to be labeled as B. So B there, we can say 4 grams of hydrogen gas reacts with 32 grams of oxygen to produce 36 grams of water. So we can say 4 grams of hydrogen gas reacts with 32 grams of oxygen to produce 36 grams of water. So 4 grams of hydrogen gas, and how we are finding 4 grams there, we know that mass is equal to number of moles multiplied by the molar mass. So mass is equal to number of moles there. We know that we have 2 moles of hydrogen gas. So we're going to say 2 multiplied by the molar mass of hydrogen gas there. So we have H2. We know that that's going to be 2 multiplied by 1, and we're going to have 2 gram per mole. So we're going to have 2 there, and that means that our mass for hydrogen gas there, we're going to have 4 grams of hydrogen gas. So that's where the 4 grams is coming from. Then 32 grams of oxygen gas there. So we to calculate the mass of oxygen, its mass equals to number of moles multiplied by the molar mass. Mass is equal to number of moles. We know that we have 1 mole of oxygen gas there, so we're going to say 1 multiplied by the molar mass of oxygen gas. So there we know that we have a 2 multiplied by 16, and that's going to be 32. So mass is going to be 1 multiplied by 32. So our mass is going to be 32 grams of that of oxygen gas. So that's where the 2 is coming from. Then let us look at on how we are coming up with 36 of water. So 36 grams of water. So we'll say for H2O, so we know that mass is equal to number of moles multiplied by the molar mass, and mass is equal to number of moles there. Number of moles of water, we know that that's 2 moles, so we will say 2 multiplied by the molar mass of H2O. We know that we have H2O there. That means that we're going to say 2 multiplied by 1, and that's 2. Then we also have 1 multiplied by 16, and that's 18. And that's 16, sorry. We're going to have 16. So 1 multiplied by 16, that's 16. And to add that, we're going to have 18. So 2 multiplied by 18 there. Mass is equal to 36 grams. So 36 grams of water, H2O. So that's where the 4 grams, the 32 grams, and 36. So 4 grams of hydrogen gas reacts with 32 grams of oxygen to produce 36 grams of water. Let us now look at our examples. So our first example reads, calculate the mass of carbon required to reduce 7.95 grams of copper 2 oxide to copper according to the equation. So we have copper 2 oxide plus carbon is equal to copper plus carbon dioxide. So the first thing that you need to do is to ensure that the equation that you have been given is a balanced chemical equation, and this equation is already a balanced chemical equation. Then from there, we're going to collect our data. And from the data there, first thing that we're going to find is the mole ratio. So we are going to find our mole ratio, and our mole ratio, you can say that we have 2 moles of copper 2 oxide there reacts with 1 mole of carbon. So 2 moles of copper 2 oxide reacts with 1 mole of carbon. So that's going to be our mole ratio. So let us write that down. So 2 mole of copper 2 oxide reacts with 1 mole of carbon. So that's going to be our mole ratio. Then let us now look at the mass ratio. So for the mass ratio there, we're going to start with that of copper 2 oxide. So we have copper 2 oxide. So we're going to say mass is equal to number of moles multiplied by the molar mass. So mass is equal to number of moles. We know that we have 2 moles of copper 2 oxide. So we're going to write down 2 multiplied by the molar mass. If you find the molar mass of copper 2 oxide, you're going to get 80. So mass is equal to 2 multiplied by 80. We're going to have 160 grams. Then let us find that of carbon. So carbon, we're going to say mass equals to number of moles multiplied by the molar mass. Mass is equal to number of moles there. We know that 1 mole of carbon there, so we'll say 1 multiplied by the molar mass. If you check the mass number on the periodic table of carbon, that's 12. So put our 12 there. Mass is equal to 12 grams. So here we can write in this form. So we are going to say 160 grams is reduced by 12 grams of carbon. What about the mass of carbon that we have been given, the mass of copper 2 oxide that we have been given in the question, which is 7.95 grams of copper 2 oxide. So we're going to write this here. So this is going to be 7.95 grams of copper 2 oxide. It's going to be equal to X. So we're going to cross multiply there. So we're going to have 160 X is equal to, we're going to have 12 multiplied by 7.95. So divide by 160, divide by 160. So if you perform your calculations there, the answer is going to be equal to 0.596 grams of carbon. So that's going to be our answer. Question 2 reads, calcium reacts with water to form an insoluble suspension of calcium hydroxide. Hydrogen gas is produced. Calculate the mass of hydrogen gas produced from 10 grams of calcium. So we already have our balanced chemical equation. So the first thing that we're going to do is to collect our data. And our data, we're going to find first the mole ratio. So that's the first thing that you're supposed to find, the mole ratio. In the mole ratio, we're going to say 1 mole of calcium produces 1 mole of hydrogen gas. So here we're going to concentrate on elements that are affected. And if you read the question, it reads, calcium reacts with water to form an insoluble suspension of calcium hydroxide. Hydrogen gas is produced. Calculate the mass of hydrogen gas produced from 10 grams of calcium. So we're going to concentrate on calcium and hydrogen gas. We're going to only concentrate on these 2 elements. So the first thing that I've said, we are going to say 1 mole. So we know that here we have 1 mole of calcium produces 1 mole of hydrogen gas. So we're going to write down that mole ratio. So we have 1 mole of calcium produces 1 mole of hydrogen gas. So that's the first thing that we're going to do. Then after that, we're going to find our mass ratio. And to find our mass ratio there, we're going to say 40 grams of calcium produces 2 grams of hydrogen gas. So we'll say 40 grams of calcium produces 2 grams of hydrogen gas. And how we are finding this number of masses of calcium and hydrogen gas? So if we start with that of calcium, we know that mass is equal to number of moles multiplied by the molar mass. So mass is equal to number of moles. We know that we only have one there, 1 mole of calcium multiplied by the molar mass of calcium. If you check on the periodic table there, it's 40. So the mass of calcium, we're going to have 40 grams. Then what about that of hydrogen gas? So how these two is coming about, so we're going to say mass is equals to number of moles multiplied by the molar mass. Mass is equal to number of moles from the equation. We only have 1 mole of hydrogen gas multiplied by the molar mass of hydrogen gas, that's 2. So mass is equal to 2 grams. So that's where the 40 grams of calcium produces 2 grams of hydrogen gas is coming. So after that, we're going to say 40 grams of calcium produces 2 grams of hydrogen gas. What about the number of mass that we have been given in the question? Then we're going to check the mass that we've been given in the question for calcium. So we have 10 grams of calcium. Then we're going to say 10 grams of calcium will produce X grams of that of hydrogen gas, and we're going to close multiply there. Then if we close multiply, we're going to have 40x is equal to 10 multiplied by 2 there. We're going to have 20. So divide by 40, divide by 40. Our x there is going to be equal to 20 divided by 40. We're going to have 0.5 grams of hydrogen gas. That's going to be our answer. Question 3 reads, calculate the volume of hydrogen at room temperature and pressure produced from 1 cubic decimeters of ammonia in the element below. So I've said the first thing that you need to ensure is to ensure that the equation that you've been given is a balanced chemical equation. So as you can see, the equation is balanced, but we're going to only consider the compound and the element which is affected. So from the equation says calculate the volume of hydrogen at room temperature and pressure. So here you can underline hydrogen produced from 1 cubic decimeters of ammonia. So we are going to concentrate on ammonia there and hydrogen gas. These are the two compounds and elements that we are going to concentrate on. So the first thing that we are going to do there is to write down the data there. And for our data, we're going to find the mole ratio. And for the mole ratio there, we can say 2 moles of ammonia produces 3 mole of hydrogen gas. So here, as you can see, we have 2 moles of ammonia produces 3 moles of hydrogen gas. So that's the first step that we're going to write down. So we'll say 2 moles of ammonia produces 3 moles of hydrogen gas. So that's the first thing that we're going to do, and we know that we are supposed to calculate volume there. So we're going to find our volume ratio, and for our volume ratio there, we're going to start with that of ammonia, and we know that volume is equal to number of moles multiplied by the molar volume. So volume is equal to the number of moles of ammonia there. From the equation, we have 2 moles, so I will say 2 multiplied by the molar volume, and we know that we have been told at room temperature and pressure, and the molar volume at room temperature and pressure, it's 24. So the volume there is going to be equal to 2 multiplied by 24. We're going to have 48 cubic decimeters. Then let us calculate the volume of hydrogen gas. So volume is equal to number of moles multiplied by the molar volume. So volume is equal to number of moles there. We have 3 moles of hydrogen gas, so 3 multiplied by 24. So volume is equal to 3 multiplied by 24, that's 72 cubic decimeters. And since we have calculated the volume ratio, we can now calculate the volume of hydrogen gas that was produced. So here we can say 48 cubic decimeters of ammonia produces 72 cubic decimeters of hydrogen gas. What about 1 cubic decimeters of ammonia is going to produce X volume of hydrogen gas? So that's the thing that we're going to write down. So we'll say 48 cubic decimeters of ammonia produces 72 cubic decimeters of hydrogen gas. What about 1 cubic decimeters that we have been given in the question? This will produce X volume of hydrogen gas. So we're going to cross multiply. So we're going to say 48 multiplied by X there. We're going to have 48X is equal to 1 multiplied by 72. We're going to have 72. So divide by 48, divide by 48. So X is equal to 1.5 cubic decimeters of hydrogen gas. That's going to be our answer. So question 4 reads, calculate the volume of hydrogen gas produced from 3.01 cubic decimeters of magnesium at standard temperature and pressure. The reaction between magnesium and steam is given below. So we have magnesium plus steam is equal to magnesium oxide plus hydrogen gas. So I said the first thing that you need to ensure is that the equation that have been given is a balanced chemical equation. So as you can see, that's a balanced chemical equation. And from there, you're going to identify the compounds or the elements that are affected, or the ones that you need to find. So from the question there, we have been told that calculate the volume of hydrogen gas produced from 3.01 cubic decimeters of magnesium. So we know that magnesium there and hydrogen are affected. So the first thing that we're going to do is to write down the data. And for the data there, we're going to find the mole ratio. And for the mole ratio there, we're going to say 1 mole of magnesium gives 1 mole of hydrogen gas. So we have 1 mole of magnesium gives 1 mole of hydrogen gas. Then from there, we're going to write down the volume ratio. Then for the volume ratio, we can say 22.4 cubic decimeters of magnesium gives 22.4 cubic decimeters of hydrogen gas. So we say 22.4 cubic decimeters of magnesium gives 22.4 cubic decimeters of hydrogen gas. And the reason why you have 22.4 cubic decimeters of magnesium there, we know that volume is equal to number of moles multiplied by the molar volume. And the number of moles there, we know that that's 1 of magnesium. And the molar volume at standard temperature and pressure is 22.4. So we're going to say 1 multiplied by 22.4. So we're going to have 22.4 cubic decimeters. And that's going to be the same with that of hydrogen gas. So to find our answer there, we are going to say 22.4 cubic decimeters of magnesium gives 22.4 cubic decimeters of hydrogen gas. Then what about 3.01 cubic decimeters of magnesium that you have been given in the question? So if you check in the question there, we are told to calculate the volume of hydrogen gas produced from 3.01 cubic decimeters of magnesium at standard temperature and pressure. So we're going to cross multiply there. So we're going to have 22.4 x is equal to 22.4 multiplied by 3.01. So divide by 22.4 divide by 22.4. So x there is going to be equal to 3.01 cubic decimeters of hydrogen gas. So that's going to be our answer. So for question 5 and 6, make sure you find these answers and share them in the group. So question 5 reads, calculate the volume of carbon dioxide at room temperature and pressure produced from 10 grams of calcium carbonate. Write a balanced chemical equation. Question 6 reads, calculate the mass of calcium oxide produced when 14.8 grams of calcium hydroxide are heated according to the equation. So we have calcium hydroxide there that produces calcium oxide plus water. So make sure you find these solutions and share them in the group. Where you have questions, please ask.